Welcome to homework.
The entropy for a given process is given by delta S is equal to Q over T. Here we have entropy that comes from a 3 steps process. Number first, we have a loss of entropy delta S that comes from a water to freezing. So water to freezing becomes ice freezing. In this process, then we can write our entropy. So let's say our entropy delta S comes from 3 processes of entropy. So our delta total entropy is delta S1 comes from a first step, and the delta S2 that comes from a second step, and delta S3 that comes from the third step. So the first step, which I explained here, is the comes from the loss of entropy from water that goes into a freezing, into ice. Then we can write a delta S as delta S1 will be equal to Q1 over T1. Then our Q1 will be mass times latent heat of fusion for ice over T1. By plugging the values of mass and latent heat of fusion, then the answer here we get for delta S1 here is a minus 1.219 times 10 to the power 6 joules per Kelvin. In second step, ice is cooled to minus 10 degrees. So we have ice then which is cooled down to minus 10 degrees. Then we represent this as entropy delta S2, which is equal to minus mass times specific heat of ice times delta T, 2 change in temperature, divided by T2, where a mass is given, which is 10 to the power 3. Our ice specific heat is 2100 times the change in temperature we have at 10. So divided by, so this is 10 to the power, so here we have a minus sign, times 2100 times the change in temperature is 10 divided by T2 is a minus 5 plus 273, and this gives us the entropy delta S2, which is minus 7.8358 times 10 to the power 4 joule per Kelvin. 10 to the power 4 joules per Kelvin. In third step, the gain in entropy is the heat lost from the water that goes into ice. So the heat lost during the process of 1 and 2. Then we can write delta S3, the entropy in third step we can write here is Q3 over T3. Our Q3 becomes mass times latent heat of fusion plus mass times the specific heat of ice times delta T2 divided by T3. So we already solved for the numerator for this term, these two terms in numerator. So then we will plug the T3 here, and this gives us the entropy of 1.346 times 10 to the power 6 joules per Kelvin. So as we said earlier, so delta S is a delta S1 plus delta S2 plus delta S3. We have got all of these three terms. So the only thing we need to do here is to add up these terms, and the total change in entropy we get here by adding this term, this term, and this term, we get the total change in entropy is approximately 5 times 10 to the power 10 to the power 4 joules per Kelvin. So this is our answer. End of the problem. Thank you for watching.